This is Mariam Siddiqui, and today we will be learning a topic from GCSE Chemistry 8462. Before getting to know that which topic we will cover today, I would like to draw your attention toward the methodology we will follow. Number one is theory. In this, we will understand the topic and cover all the aspects that is mentioned in the outline of the board. Next, practice. We'll be practicing some example questions and implement whatever we have learned in the theory section and try to solve the questions together. Lastly is test yourself. In this, we'll be doing the past paper questions. So today's topic is metallic bonding, which is a subpart of bonding, structure, and properties of metal. This is basically the outline that is provided by the AQA board. So what actually metallic bonding is? Metallic bonding is an electrostatic attraction between the positive ions in a giant metallic lattice in sea of delocalized electrons. Here you could see a lot of words are bold and maybe the font size is bigger. Basically, they are the keywords which our examiner is expecting from you, such as electrostatic attraction, positive ions, giant metallic lattice, and sea of delocalized electrons. Positive ions. The metal atoms are electropositive in nature, therefore, they lose one or more electrons to become cations. If we talk about sea of delocalized electrons, this means the electrons occupy the space between the metal ions and are free to move throughout the metal. In this diagram, it might be clear that you can see there are positive ions, there is sea of delocalized electrons, and this seems to be the regular pattern, regularly arranged. In further detail, look at the structure of metal. If the question comes to draw the structure of a metal, this is what examiner expect from you to draw. There are three main things which we have to focus. Number one, that it is the positive ions and delocalized electrons that has to be labeled. Next is the order, which basically matters a lot. You could see that the positive ions are in levels. They're not disorderly arranged. To clear your view more, I would like to show you a video on metallic bonding.
Describing the electrostatic attraction between the metal ions arranged in a lattice structure and the free-floating electrons around them. Since these electrons are free to move around, the term sea of electrons is also used.
Hopefully, now it's very clear how the structure of metal looks like and what are the terms you can use to describe the metallic bonding. Let's sum up. Within the metal lattice, the atoms lose valence electrons and become positively charged metal ions. Here, I would like to mention that without any doubt, when we learn chemistry, every topic is interlinked. So, when we talk about positively charged metal ions, either the word could be this, or if it is written cations, so we know that cations are the atoms that lose their valence electrons to become positively charged metal ions. Next, next, the valence electrons no longer belong to any specific metal atom and are said to be delocalized. So here, you could extract the knowledge that where these series of delocalized electrons are coming from. Hence, the statement comes that they can move freely between the positive metal ions and act like a sea of electrons. Next, we will be discussing about the properties of metals. First thing is high melting point.
Attraction and explains why metals have high melting and boiling points. A lot of heat energy is needed to overcome this attraction.
So, if the question comes that why the metal have a high melting point, so you could say that a lot of heat energy is needed to overcome this attraction, the strong electrostatic force between the cations and the sea of delocalized electrons. Another property is that metals are good electrical conductors. Okay, so what make them, why metals are known that they are good electrical conductors? The key word here is delocalized electrons. When we pass an electricity through metal, we are basically passing free electrons which are available to move and carry the charge. In metals, there are already the free electrons, so there is a repulsion between those electrons. Hence, electrons can flow, and this flow is the thing which is going to create the electricity and hence making metals a good conductor. So here you could see the question that why are metals good conductors of electricity? By this we could say that all of above. Now, there's a trick to solve the MCQs, there is a trick to solve the multiple choice question, and that is that eliminate the option which you are sure that it's not the answer. Number one, metals have high melting point. Yes, they do. They gain electrons easily. Is it? No. As we have learned that metal atoms loses an electrons to become positively charged ions. So we eliminate the B part. Moving on to the C, they have low resistance. And the last is all of above. So here we could eliminate B and we could eliminate D. Considering the high melting point and low resistance. As discussed before, the melting point is something which we relate to the strong electrostatic force. So here we could eliminate that point, and the last is that they have low resistance. Although we didn't learn specifically that they have low resistance, but by the theory we learned, we could conclude that the C is the right answer. So whatever I discussed earlier is mentioned here, and the correct option is C. The last property which we are going to discuss about metals is that they are malleable and ductile. Malleable means that they can be molded into different shapes. Ductile means that they can be stretched into wires. So pure metal contains metal cations of the same size and arranged in a regularly ordered manner, allowing the layers of cations to slide over each other easily. Now, second step, practice the questions. Now here are the statements that metal contain a lattice of negative ions in a sea of electrons. The electricity conductivity of metal is related to the mobility of electrons in the structure. So, which statement is correct? One or two or both? Again, metal contain a lattice of negative ions in a sea of electrons or a positive ions in a sea of electrons? Yes, positive ions. Next, the electrical conductivity of metal is related to the mobility of the electrons in the structure. True. So, we know that statement 2 is correct. Going through the MCQ's option, we know that D is the correct answer. Statement 2 is correct and statement 1 is incorrect. Another question. A metal consists of lattice of positive ions in a sea of electrons. See, here it is, positive ions. What happens to electrons and positive ions in a metal wire when an electrical current is passed through it? Again, does this affect the positive ions or it only affects the electrons? We know that when electricity is being passed, so electrons are affected. So they're replaced by new electrons. But positive ions remain unchanged. So the answer is B, replaced by new electrons and unchanged. One more question. X, element X has a lattice of positive ions and sea of electrons. Which property will X have? It conducts electricity by the movement of ions and electrons. Now, this statement is false. Only the movement of electrons. It has a high melting point. Yes. It is decomposed by electric current. No. It is not malleable. Absolutely not. So the answer is it has high melting point. Getting something theoretical, that practice question comes that explain why metals are malleable. We know we could refer to the layers. Malleability is that layers can slide over each other. So you could see that the 2 points here reference to layers and the layer side. Second point, metal conduct electricity. We are now it's very clear that it's because of mobile electrons or electrons can move. Next is that what are the physical properties which are characteristics of metals, and this other is bold, that means that we have to mention something which is not related to electricity or thermal conductivity, that is the melting point and the boiling point. So the answer comes here is the ductile, malleability and shiny. So we could write ductile, we could write malleable. Towards the end of our lecture, test yourself. So this is the past paper question and I expect you to answer it, try to answer it on your own. So the question is about aluminum. Aluminum is a metal. So we have to draw the line from the property to the reasons. So what do you think that what was the reason for the conduct electricity? Is it aluminum has dielectric localized electrons? Aluminum can slide. Aluminum has strong metallic bonds. It has weak intermolecular force or a random arrangement of atoms. So we know no random arrangement of atoms. They are regularly arranged. They have strong intermolecular force. So cancer. So then can atoms slide over each other? Makes it like good electrical conductor or having a high melting point? No. So we are left with two top options, that is aluminum has delocalized electrons and aluminum has strong metallic bonds. So I know you have guessed the answer. Hopefully, so conducts electricity is aluminum has delocalized electrons. High melting point is because of they have strong metallic bonds. Next question. Although this is combinations of topics, but focus the substance is a solid metal. Which diagram or which structure represents that substance is a solid metal? Let's have a look at the answer. Hopefully, you guess the right answer. And this is all from us. Best of luck, and we'll be providing a lot of notes and practice questions in order to get yourself prepared. Join us, and hopefully, the topic is very well clear to you. Thank you.